Hey, and welcome to Season 2 of the ProtoPod, the podcast for engineers, innovators, entrepreneurs, and trailblazers shaping the future. I'm your host, Jordan Rose. Today on the ProtoPod, we're excited to welcome two student leaders from UGA Rocketry, Brooklyn Schnupp and Parsa Novin. As part of the University of Georgia's student rocketry team, Brooklyn and Parsa competed in the International Rocket Engineering Competition earlier this year, which is the world's largest intercollegiate rocket event. They'll be sharing what it's like to lead a student rocketry team, the challenges and breakthroughs of building rockets from the ground up, and what excites them about the future of aerospace. Let's get into it. Brooklyn, Parsa, welcome on to the ProtoPod. I'm really excited to chat with you guys today. I know you're both members of the UGA Rocketry team, both in different capacities. We'll get to that. I just would like to start by finding out what drew both of you to aerospace engineering.
So I guess I'll start. I have always loved flying and rockets and airplanes. I remember going on trips with my family, and I just love being able to look out the window whenever you're flying and being up really high. As far as engineering, my dad taught me how to use a lot of tools when I was younger. I was always helping him fix lawnmowers and work on some small machinery. So that was always really cool to me, and being able to combine the two of them into aerospace engineering has always been really cool.
And I think for me, I was actually originally a robotics kid in high school. All I ever did was robotics. I was on a robotics team. I loved robotics. And then when I came to high school, my high school didn't have, or when I came to college, my high school didn't have any kind of aerospace program or like any rocketry programs. So college was really my first like experience getting to try out aerospace and seeing how I liked it. And I like immediately fell in love with it. But like I've always been in engineering. Just like as a kid, that was kind of my thing. I liked making things. And then like when I came to college, the kind of concept of like rocketry as a whole, it just kind of speaks to me because rockets, they kind of represent a lot to me, like ambition wise. It just seems really cool to try and like reach for the stars.
Yeah, I think that's a really great point. They are very ambitious, and they're kind of the cutting edge of technology and, humanity's reach for space. And I think you guys have definitely chose very interesting fields. I'm wondering, I know both of you have different disciplines of engineering that you're studying, and I would imagine you have different capacities or different roles on the team. Do you want to give us a little more detail as to what your roles are on the team?
Yeah, so both Parsa and I are the co-leads for this year's IREC team. We started on the team the first year that we ever competed, and we were both basically shadows back then, and now we're leading it together. And so I work on a little bit of the project management side and then also the systems engineering side. So really making sure that all the pieces fit together and all the sub teams know what the other teams are doing and can work between the different sections. And then Parsa can talk about his role.
Yeah, so I'm an electrical engineer, but historically, I've had a lot of experience with CAD and design. So I'm the chief engineer for this year, which means I come up with like all the designs, and then I force Brooklyn to go through the process of integrating everything, no matter how bad the integration might be. But it's kind of like the system we have where I come up with basically the prototypes or like the ideas for the designs, and then Brooklyn goes through and refines them and makes sure they're actually possible.
Okay, very interesting. I understand that at last year's competition, your team was very successful. Can you give us a rundown of how you performed?
Of course, yeah. So we were actually really excited. So last year we got 6th place in our category, and it was out of 87 teams, I think, and then 10th overall out of 172. So we did really well, especially for our second time competing. Our apogee was a big increase. Our first year we got about 9,000 feet, almost exactly. And then this past year we got almost 9,900. So big improvement and really encouraging for the whole team.
That's incredible. I'm really curious. I obviously you're both students, and you're balancing this project or this development with your schooling. I'm curious as to what the improvements were, maybe not even from a technical perspective, but from how you guys executed the changes to your design in order to improve the performance. Like, you have both very unique perspectives on this. Brooklyn kind of trying to keep everybody rowing in the same direction, and Parsa making sure that the pieces are well designed. So what was the difference?
Okay, I'll take this one too. So I think one of the biggest things is that we got our timeline working really well. So the first year that we ever competed, we started the application process, and we ended up like building most of the rocket, but then we didn't have enough funds and we didn't have enough students and everything to actually make it to the competition. So we did have to drop out our first year, and then our second year, we made it to the competition using the same rocket. So we kind of imagined our first year as like a 2-year long process. It was still using the same design and everything, but it kind of got extended. And then this past year, it was really different to try to do everything within 1 year, from the application process to all the reports, and then also like designing and building the rocket itself and traveling out over the summer. So a lot of that was like really focusing on the timeline and making sure that every student knew exactly what they had to do, and they were aware of all their responsibilities, and that way we could all get it done, and we had some good deadlines to work on. So that was really helpful.
And I guess from a design perspective, our aerospace program at UGA is still developing. So it was kind of like building that team experience, and just like making sure that everyone had actual experience, because like, again, that was like our first year ever doing something to this scale. And then after that year, all our people who were in charge, they left, and it was basically just the few of us that were actually on the team and stayed to kind of pass down the knowledge and train everyone back up.
Interesting. I know, Parsa, earlier you had mentioned that the integration can be rough, and I can well imagine with all the subsystems that are required, the complexity of the design, and all obviously as well the limited timeline that you've alluded to. I'm just curious if you guys have learned anything about how to make that process smoother. Like, have you implemented any design methodologies or project development methodologies in order to execute given those constraints?
That's actually a really good question. And that's really where ProtoSpace has come in and helped us a lot. So as you might know, we have a $1,000 award that we get every year for competing in IREC. That's free machining with ProtoSpace. So in the past, we've always tried really hard to make sure that we're using that machining money for the absolute most that we can get out of it. And usually that means designing a part and building it for something that can be reused year to year and something that's very adaptable. Our first year, we built our payload bay. So it's a fully machined payload structure that matches our CubeSat requirements for the competition. And then this past year, we built something that a transition. You can actually see it right here. So we made it super adaptable, and we've always tried to design things and integrate them to where we can reuse them from year to year, because we don't have the same budget as some of these other teams. But it just makes us work a little harder and do some more engineering.
Yeah, I think that's, thank you for the compliment first. But I think it's a really great point. We talk about that internally. Kind of under what we try to do here is provide people with the ability to move at speed, and not kind of get bogged down in what we like to call project black holes, when something doesn't work right. And I think, designing for reusability is a really great idea in that regard. It kind of takes what we would call unknowns out of the equation, where something is going to work. So therefore, you can kind of eliminate the time for testing that's required. I think it's a really great point. I was also wondering, I know that since you guys have had such a breadth of experience on the team, kind of starting out at the ground level, as you said, now to being the co-leads, I'm curious, what sort of leadership skills do you think you've developed over that time, and how has that kind of helped you both in the team and then outside of it?
I will say, I think the biggest leadership skill that I've gained has been being able to take people's skill sets and being able to make an adequate workload for them, and generally just offloading tasks from myself, because when you're in a leadership position, sometimes it feels like you need to be doing the most, but at a certain point, you start doing too much, um, and putting your faith in people, um, and just letting them do the tasks, and if they don't do the task that you want, that's okay, because you still have time and they're learning from it, so you're also training them up in that experience. But just offloading these tasks and knowing people's limits, I think that's the biggest thing I've gained.
Brooklyn, what about you?
Um, Honestly, it's been really fun to jump between the different roles and everything. It was always exciting when I was able to do some of the more technical skills, but then it just like what Parsa said, having to delegate and separate out those tasks to the different people. Um, it's there's I see the fun in both of it. It's great to be able to know what somebody's skill sets are and be able to assign them something that's specifically based off of that, but then also help them out with it and maybe increase their technical knowledge by working on something new.
Yeah, I think you guys raised really great points about leadership, and that at the end of the day, it's more about vision and alignment than doing all the work for everybody. And a really important skill to learn in that capacity is the ability to delegate, and who you can delegate it to, who has the skills in order to delegate that to. There's some very interesting leadership methodology that kind of talks about how you break down delegation, and it very much involves those steps. So I think that's really cool that you guys have learned that during this process and growth within the team. I'm wondering if anybody listening is interested in getting involved, either at UGA or another school. What advice would you give them to be successful on a rocketry team?
Honestly, the best thing that I would say is to build a level 1 rocket and launch it at a local launch site. So all the rockets behind me are level 1 and level 2 rockets that people have built individually. This pencil right here is my level 2, if you can see it. But really, working with the basics of high power rocketry, even if you're starting with a small Estes kit that launches on an E motor or something really small, it really teaches you about the fundamentals, and then you're able to increase from there.
Parsa, what about you?
I would say starting out from the absolute base level, it's okay to not know things. I know rocket science, it's always this crazy term that it's the hardest thing you can do, and it can be pretty hard at times, but we're all students in college, and starting out from the base level, it's okay to not know things. Most of the time when we're looking for new applicants for the competitive teams, we're really looking for just raw um oh how do I phrase this?
Determination.
Yeah, determination and just passion for what you want to do in aerospace, and the skills that you build will follow the passion that you have. So it's really just being able to focus on this one thing that you have a passion for, which it can be hard to know if you do have a passion for it, but that's why try everything, and then when something sticks, just really focus on it.
Yeah, I think that's good advice. It's the you're looking for aptitude and attitude above anything, and it doesn't necessarily mean that people have to have specific knowledge. I'm curious, do you have any advice, Parsa, if you come into that environment and you run into things that you don't know? How have you in the past? Feel free to answer as well, Brooklyn. How have you gone through the process of learning?
So I think in engineering, you're really taught a lot of first principles, and first principles are very useful for so many different things. But I think one of the engineering philosophies I live by is that someone has done it better. So when you're designing something, or when you're looking to combine two designs into one, there's almost always a research paper or some kind of design that has been made by someone at the professional level that you can look at and you can reference, and you don't always have to copy it exactly because application to application is always different. But um, it's generally just research and like looking for these designs that already exist that can either bring you inspiration or just bring you the solution.
Brooklyn, anything to add?
I think you did a great job.
I think it's a really great point. I it, the term I would use there is steal somebody else's 10,000 hours, and learn from that. And Brooklyn, I liked what you had said earlier as well about kind of scoping down to that level one. It just takes away some of the uncertainties of the more complicated builds and allows you to, have a smoother experience and not kind of lose velocity. You can maintain momentum because there's less things to kind of catch you. I think that's really, really sound advice. So I guess for both of you, I know you're both still in school and working your way through your master's or your undergrad. What's next for you guys? What's the future hold? Where do you want to end up?
I guess I'll go first again. My dream job has always been in hypersonic aircraft. I think it's always really cool, and I think that there's a lot of overlap between rockets and airplanes. I would love to work in either industry, but honestly, wherever the wind blows, I think it's all super cool, and I think there's a lot of great opportunities, especially right now. So, yeah.
So I'm still in my undergrad, so I have the entire world ahead of me. But I am pretty sure I am going to get my master's after my undergrad. So looking for somewhere fun to do that. But I do want to stay in ECSE. I don't think I'd do like a full aerospace degree because I'm just a lot more interested in the actual electronics and applications of like control systems and rockets. So being able to like actually get my master's in some kind of electrical or computer engineering and then being able to apply it in industry, that's kind of where I foresee myself going. And in the very far future, maybe a PhD, because I do think it would be really cool to like actually learn a lot of the actual fundamentals of either aerospace or just like control systems, and maybe go into academia or professorship for that.
Awesome. Well, I'm very excited to see where you both go. Maybe we'll see you down at the competition this year. I know we will be there. Before we conclude, I would like to run through our rapid fire question segment. First answer that comes to your mind, we'll maybe go Brooklyn, then Parsa for this, just to keep it simple. So if you guys are ready, I'll dive into it.
I'm ready.
Yep.
I'm excited.
First one, Moon or Mars?
Moon for sure.
Moon.
Interesting. Rover or rocket?
Rocket.
Yeah,
Rocket.
that was a gimme. Coffee or tea?
Tea.
Coffee.
Early bird or night owl?
Night owl.
Night owl.
Lots of late nights at UGA Rocketry. Favorite tool, gadget, or piece of tech that you own?
A basic adjustable wrench. It's very useful.
This is really basic, but a laptop.
Yeah, good answers. Parsa, you already kind of answered this, but feel free to answer again. One engineering principle you live by?
Ooh, that's hard. Parsa, you can go first.
It's still going to be take someone else's 10,000 hours. That was a great way to put it.
I think mine would be like optimize, or just continue optimizing. Like it can always improve.
Really good advice. Worst learning from failure moment in your studies?
I remember I got a 15 on an exam once. That was before the curve, thank goodness. But I did get a 15, and I thought I would have to drop out of engineering. It was actually my junior year, so I had taken some engineering classes already, and I was like, this is the end. But I kept working, and I made an A on the next exam, and I worked really hard and brought my grade back up. So it was really stressful, but it's not the end of the world if you fail an exam.
Yeah, that happens to everybody.
I think in electrical engineering, I feel like it's a little bit different from mechanical because you start with tests, but then you eventually move on to project-based classes, um, and they are so different. But I think there's been a lot of times where, like in the early project-based classes, I've had a sensor system or like something on a microcontroller that has been on a different ground level than whatever I've been trying to read, and I did not even think to check it until hours in because I just that can't be the issue. It can't be that simple, but um, sometimes really it is just the simple things that are wrong.
Start with the basics. Last one. If you could instantly solve one challenge with your rocket, what would it be?
I really want to work on hybrid rockets. And honestly, our biggest challenge with that is funding. So if we could have unlimited funding, we could basically do anything.
In terms of, I think like the actual rocket itself, it would probably be heating issues because that thing gets hot. All the electronics produce so much heat, and then it's also just sitting in the sun for so long. We've had our camera shut down so many times, and we've lost footage because it was just too hot to record. So I think being able to solve that would be pretty nice.
Two really good answers. Well, again, thank you both so much. It's been really interesting getting to learn a little bit more about you and what you're doing down at UGA Rocketry. And as I said, I look forward to seeing you guys and your rocket at IREC this year.
Yeah, we look forward to seeing you too.
Okay, thanks, guys. Until next time.
Thank you.
Bye-bye.
See ya.